Fundamental Resonance, Episode 1, Sonic Cartographies, an audio journey through the echoes of the cosmos. In this collage, you can hear the sounds of particles colliding, the cosmic microwave background, plasma waves, and gravitational waves, energies that have been present throughout the universe since its inception. Listening to them provides us a new way to experience the patterns and structures that have shaped and will continue to shape our universe. To clarify, these are not literally sounds from space. What you're hearing right now are artifacts of energy translated into sound. Electromagnetic energy, X-rays, and radiation captured by observatories on Earth and in space that we are able to hear through sonification. Sonification is the process of turning data into sound. Exactly how does that work? Audification is the most direct form of sonification. Data, such as the electromagnetic energy created when plasma waves interact with the atmosphere of a planet, are played back as sound without much transformation, simply by shifting the waveform into an audible range. This method allows us to listen to raw phenomena, like the radio waves emitted by distant stars. In parameter-based sonification, specific aspects of data, such as the speed, frequency, or atomic density of one particle as it collides into another, are mapped directly into properties of sound, like pitch, volume, or tone. Parameter-based sonification translates data patterns into distinct sonic features, creating a more familiar auditory experience. Parameter-based sonification sounds more like music. Model-based sonification, on the other hand, recreates a physical processor system using algorithms to mimic the behavior of that system. Sounds are not directly selected or composed, but rather generated by the interaction and evolution of the model and its underlying mathematical principles. In this way, model-based sonification has a lot in common with techniques used in the composition and performance of electronic music, such as algorithmic composition and granular synthesis. To understand how plasma waves, particle collision, gravity, and the cosmic microwave background are related to each other, and how the patterns of energy created by these phenomena continue to shape the cosmos, we have to start at the beginning of everything. The story starts 14 billion years ago with the Big Bang, which was not so much a bang, but more an expansion of a dense and very powerful amount of energy. The universe at this time was a hot and chaotic mass of plasma. This plasma was made up of protons, electrons, and photons. Photons are light. The gravitational affinity that the protons and electrons had for one another kept the plasma together, but light, having no mass of its own, was ready to make an escape from the plasmic soup and begin its infinite journey across time and space. This push and pull between light and gravity caused disturbances in the plasma called acoustic oscillations. These acoustic oscillations were technically sound waves, moving through plasma rather than air, but no one was there to hear them, and if they had been, there would have been no sound. As these ancient sound waves moved through the plasma, they created patterns within the protons and electrons, compressing particles together and creating areas of high and low energy. As the universe began to expand, the particles making up the plasma cooled, turning to gas. Because of this cooling, something incredibly important happened. The protons and electrons that had been squeezed together by the sound waves formed hydrogen and helium atoms, the first building blocks of all the elements to come. In this process, the hydrogen and helium adopted many of the free-floating electrons that had been crowding up the space. This extra room and reduced ionic charge created an environment that allowed the atomically weightless photons to escape the pull of gravity and begin their endless travel across the universe. Light as we know it was born. A few thousand years after this disbursement of photons, gravity, the ultimate lurker, started to exert its ineffable force upon the particle clusters that had been formed by the acoustic oscillations within the plasma. More and more particles grouped together attracted more and more particles, eventually creating the regions of the universe where stars and galaxies would form. The energy from the light that was freed during those early stages of cosmic formation is still observable, but not with the naked eye. Known as the cosmic microwave background, this faint trace of radiation is the first light in the universe and is still detectable as electromagnetic energy throughout space today. After plasma cooled to gas and light escaped, forming the cosmic microwave background, the audio oscillations that had created these original clusters of matter were now lost to the vacuum of space. The sound waves stopped. The push and pull of light and gravity that had created the waves ended, and the universe began to grow and expand. An interesting thing happened then. The distribution of matter did not change. The dense areas remained dense, and the empty areas remained empty, even though the sound waves that had caused the particles to arrange themselves like that in the first place were gone. The parts of space where the greatest amounts of energy were concentrated became the stars and galaxies we know today, formed along the imprint left in space by the first acoustic waves. This imprint remains in the form of fluctuations of heat in the cosmic microwave background. This remnant of the distribution of energy within the plasma of the early universe is a kind of fossil record, a pattern captured in matter, left behind at the beginning of time, replicated in scale across the universe as it began to expand and grow. Through throwing rocks at the same spot in a pond, ripples move through the water, radiating outward from where the rocks are thrown. But when the rocks stop, the water stops too, locking the ripples created on the surface of the water in place. The pond is the plasma, and the waves are the acoustic waves created by the push and pull of gravity and light. The freezing of the water in place is the point at which light escaped and the cosmic microwave background was created. The ripples in the surface of the pond are the clusters of particles that were grouped into areas of greater density by the acoustic waves in the plasma. Galaxies form and stars cluster where the ripples are. As the universe grows larger, the scale of this pattern of energy and matter distribution grows with it, acting as a sort of golden mean by which to measure and predict the expansion of the universe. While the cosmic microwave background provides a picture of the universe as it was when it began, the patterns of these acoustic oscillations, frozen in time and place at the point that the cosmos began to expand, allow cosmologists to trace the expansion of the universe, helping us understand how it has grown and what it might look like in the future. As you listen to these sonic artifacts, think of the energies that left them behind, forces present at the beginning of the universe that still arrange matter across space and time. Enjoy the map. Fundamental Resonance is a production of Fulcrum Arts. Composed, written, narrated, and edited by Sam Rowell. Audio mastering provided by Sean McCann. This piece, Sonic Cartographies, was created from the following sources. Readings from the plasma wave spectrometers aboard NASA's Voyager 1 and Voyager 2 spacecraft. Sonifications of particle collisions from the CERN Large Hadron Collider. Electromagnetic signatures of plasma waves interacting with the magnetosphere were gathered by the triaxial floodgate magnetometer and triaxial magnetic search coil magnetometer aboard the Van Allen probes. Sonifications of merging gravity fields were gathered from the high-energy transmission grating spectrometer and the low-energy transmission grating spectrometer aboard the Chandra X-ray Observatory.